What happens when we encounter variable radicands? We must identify the values of the variables for which the expression is defined. Okay, so sometimes we have to say, okay, well, x has to be greater than or equal to 0 because radicands cannot be, no, radicands, I'm not going to go down that road again, radicands cannot be negative. Any restrictions on the variables must be determined from the original expression. So just to write down exactly what we learned, why are there no radicals in your answer for D? We talked about it. It's because we see this as a difference of squares, where the middle term, where it would be a times b, and in this case it would be root 3 times root 2, falls away. So the difference of squares here, if we were to factor it, x squared minus y squared equals x plus y times x minus y. So example number 2, simplify. Identify any values of the variable for which each expression is defined. So first things first, let's define our variables. We say that x has to be greater than or equal to 0 because the radicand cannot be negative. So I can do this the long way, or I can see, oh, we have a conjugate here. 2 root x plus 5, 2 root x minus 5. The 5 is the same. The 2 root x is the same. The only thing that's different is the negative and positive, or the signs between them. Since we know this, we can just use what we know of difference of squares. So you can say 2 root x squared minus 5 squared. What that becomes is that exponent goes to both. So we have 2 squared times root x squared minus 5 squared is 25. So we have 4x minus 25. Done. Now you might say, well, why don't we have to have the absolute values here? Well, it's because we've already defined x is greater than or equal to 0. So absolute values would just make this positive, but all the values are actually positive. So let's just take down a few notes on the conjugate. We're going to come back to it later in this video, or in this set of videos, but it's just good to have multiple versions of it. So the conjugate of a plus b is a minus b, or the conjugate of b minus d is b plus d. Okay, so it's just the same terms on either side, but with different signs between them. What about this question? First things first, let's define what our b's can be or cannot be. So b must be greater than or equal to 0 because our radicand cannot be negative. And since it is not a conjugate, so 7 plus 2 root b is not a conjugate of 3 minus 5 root b, we have to distribute. There's no rule here. There's no fast rule. So I'm saying 7 times 3 is 21. Actually, do you know what? I'll just write that. 7 times 3. And then I'm at negative 7 times 5 root b. And then I have plus 2 root b times 3. 2 root b times 3. Kind of going around here. Okay, so 2 root b times negative 5 root b minus 2 root b times 5 root b. So I'm going to simplify here. 7 times 3 is 21. Numbery bits go with numbery bits, and lettery bits go with lettery bits. So minus 7 times 5 is 35 root b plus 2 times 3 is 6 root b minus 2 times 5, which is 10. Root b times root b is simply b. So 21, negative 35 of some quantity plus 6 of some quantity is going to be negative 29 root b minus 10b. Now, just because we have b's here does not mean that we can simplify these together. This is the square root of b. If I were to inspect this and maybe remember from grade 10, I would say that's b to the power of 1/2, whereas this one right here is b to the power of 1. So they have different exponents, so they are not like terms. Just for kicks, what's the exponent on the b here? Do you get it? Do you remember it? Anything to the power of what is 1? Oh, yes. B to the 0. Okay? So that is all in good fun. If you don't if you don't see this specific pattern here, that's okay, as long as you know that all of these are not like terms. Now, this one is a bit of a doozer. Now, I can do this a few different ways, but my inclination is to go a little bit of a slower way, especially with this one. We can use what we know of the conjugate with this first part, because it's 3 root x, 3 root x, and then root y, so the two terms are the same. The only thing that's different is the sign between them. Now, with this one, I can follow the x plus y squared equals x squared plus 2xy plus y squared. Okay, I can follow that, and if you can expand this using this abstract rule, go for it. That's actually a really great way. It would be great if you could see that, but I'm going to be a little bit slower in expanding this one. So I'm going to use what I know of the conjugate. Just make a note here, conjugate. So I say 3 root x squared minus root y squared minus, and I'm just going to write this out, root x plus 5 root y times root x plus 5 root y. Now the first little bit is really easy. 3, so the squared goes to both of these parts of the term. So 3 squared is 9. Root x squared is x minus y minus, and then I'm going to keep this in brackets because the minus is applied to this entire thing. So I'm going to use my distributive law 2 times. So root x times root x is x. Root x times 5 root y is plus 5 root xy. And then root x times 5 root y is going to be another 5 root xy plus 5 times 5 is 25. Y times y is y. I had a friend whose kid at the age of 2 said, "Hey Dad, why is y the same as y?" Like WHY versus the letter Y. I was like, whew! That kid is scary smart. So what we need to do is we need to distribute this negative to all of the terms in this bracket. So 9x minus y minus x minus 5 root xy minus 5 root xy minus 25y. Now what I could have done is I could have tightened it up a little bit. I could have simplified because here's a like term with a like term, but we'll just do it in this line, no problem. 9x minus y minus x minus 10 root xy minus 25y. So we have a few like terms here. We have 9x minus x, so we have 8x. We have negative y minus 26y, minus 25y, so that's negative 26y. And then I say minus 10 root xy. Now, in the beginning, what I should have done is I should have said that x and y both have to be greater than or equal to 0. I was just way too excited because we have a question with a conjugate and a perfect square here. But this right here is our final answer, and we don't have any of those absolute values because we should have stated at the beginning x and y both have to be greater than or equal to 0.